my name's Nic Watt. I'm back again with another RetroArch UX UI presentation. Since the last video has been probably at least a month, a lot of life stuff has come up. And also this presentation, there's an awful lot of thinking behind what I'm about to show. So it kind of stepped out of just maybe analyzing and mocking stuff up in Figma into a little bit more analysis and planning before I could kind of get into the presentation side of things. So as you're probably aware, or maybe not, but anyway, just to reinforce it, the goal of what I've been doing is to try and help the RetroArch team improve and surface improvements to user experience. There's a lot of periodic complaints from some users about the esoteric nature or maybe the difficulty or perceived difficulty, etc., of using RetroArch. And so if you check back on the previous videos, you can see some of the work that I've done there. We're not really going to cover too much of that today. And while some of what I'm proposing does touch upon it, it's fairly kind of isolated from some of the UX changes. So today we're going to be talking about error checking and alerts, essentially, and that kind of is a summary. And it's based on some of the discussions I've had with the team is that presenting errors and figuring out how to deal with errors, say from cores or config mismatches or whatever, can be quite tricky. So I've put together some ideas and hopefully these will help the team. So the error checking alerts is basically just trying to help find a way to figure out, should we be presenting some of this information to the user? Is there stuff maybe that we should be doing in the background? If we are to present it to the user, kind of what should that look like? So I'm going to start with config files because the later proposals kind of tie back to some of this, and particularly the kind of middle section about errors and error codes will tie back to this. So it's worth starting here. So my understanding is that RetroArch stores an awful lot of data in various config or preference files. I think I'm right in saying that each core has its own configuration file, and RetroArch has at least one of its own, if not several. And so the summary of the proposals really here is finding ways, if it doesn't, I haven't dug deep into exactly how everything is done on saving and loading config files at the moment. So maybe some of these things are done already. But proposing things like CRC checks, what I call dirty flags, and backup configs, and using flags to determine the last known state of the config files might be helpful here. So in essence, my understanding of RetroArch is, there's a user using RetroArch, they make a change, and at least out of the box, it doesn't automatically save much of that work. And in fact, a lot of the times I've come, from memory anyway, come to set up RetroArch from scratch, I've had to remember to turn on save on quit, for example. And so if you do manually save, like you can do this often when you're playing about with a core and you're trying to fiddle about with settings, you have to remember to save, and there's various different things that you can save when changing a core, like the control remapping or shaders or generally the core options. And I think for some users that can be a little bit confusing. And most of that's a manual process. And my assumption is most of that's a manual process because if you break something, then every time you come back to that core, it's broken, right? There's not really a way to fix it. And that's part of what I'm hoping to kind of discuss. So also one of the things, because it doesn't auto-save, if you have made any changes, if you don't remember to manually save or don't turn on save on quit for the main RetroArch settings, then basically everything you've done has been lost. And I've definitely been through that pain point. And so when you load, obviously you load a core or you load RetroArch or whatever, RetroArch is going to load the various config files. And it doesn't really matter whether the config file is good or bad. It doesn't know that, right? It has, as far as I'm aware, no way of knowing that. And so if it loads a good config, great, things work. If it loads a bad config, then maybe the user doesn't notice, right? But n seconds, minutes, hours later, maybe it comes back to bite them. Or worst case scenario is it crashes, right? The core crashes or RetroArch crashes. And so there's no kind of catch-all process to try and help prevent the user getting into like repeatable crashable states or bad sets of configs. And then the catch-all, it seems to me at the moment for the user is just delete your config file and replace it with the defaults and start again. So what I'm trying to propose is a way maybe where we can start to massage this into a bit more of a, in inverted commas, smart system. So we catch a lot of this for the user. And we'll start to talk about that now. So what I'm proposing is when the user makes a change, and this is something we used to do, so when running my own games company, we did a lot of this. We studied a lot of how we assumed Nintendo worked, and also went to like various developer conferences and stuff. And one of the things we made a lot of use of when saving data was to set what's known as a dirty flag. Now, I'm not a programmer, so I'm not going to tell you exactly what that means programmatically. But in essence, what it did for us was any time the config was changed within our app, so the user changed a preference, it would then consider that config to be dirty. And essentially, a flag was set that made the app or game aware that that was dirty. And so periodically, let's say every frame, doesn't really matter, the game or app would go, is anything marked as dirty? Yes, okay, well, I'm going to trigger a save. And usually we would have save, it wouldn't be every frame, it would be at certain junctions like, particularly in a game, it'd be like, the level's finished. Do we need to save? Is there anything dirty? Oh yeah, cool, right, let's save. Oh no, there's nothing dirty, we don't need to save, right? And that's really useful. And so I'm proposing if RetroArch doesn't have that already, it would be a good thing to do, because by having that, it means we can start to do more auto saves at certain points, right? I would also suggest that RetroArch considers some form of a has this run successfully flag, which it also sets. And so if the user makes a change, effectively 2 flags are going to be set. 1, this config now is dirty, so it does need to be saved. And 2, we don't know if this is a good change. Therefore, has it run successfully, flag is set to 0, as in no, it's not, because we don't know yet, right? And then in essence, once the setting is past muster, so if it's core, the core is loaded up, right, and works, then we can then go, oh yes, it has run successfully, and change that flag to 1 to say it does run successfully. And also, we'd also reset it as dirty, just in case it has saved. And so the great thing we can then do, and we'll come back onto this when we're talking about loading, is when you have a combination of has it run successfully, yes or no, we can start to detect what we think is happening with this config and what we should do with it on next load, for example, right? So just following this flow, the user makes a change, RetroArch sets to this config file to now being dirty, which means we're going to need to save it in the future. It also at that point sets, has this run successfully to 0, because now we've made a change and no, it hasn't. At some point later, once the user does successfully run said change, we can then set that flag to 1, right? And if it doesn't run successfully, then we don't change it from 0, right? And the file has presumably been saved at some point. And so next time we load it, we'll be able to see whether it's 0 or 1, okay? Ideally, and it probably isn't every frame, RetroArch needs to figure out a good time to do this, but RetroArch finds all the things that have been flagged as dirty and then saves them, right? And so what I've done here is I've split them into two. So if the run successfully flag in a file is set to 1, then it should save that config, which is obvious, and then it should save a backup of that config, right? And so I'm proposing, and we'll see this a little bit later on, that every config that gets created has defaults, and they never get overwritten. So it's like, maybe config.default or default.config, whatever, right? That doesn't get overwritten, but it has the user settings that have been started at defaults and then modified. They get saved, and then a backup of that one gets saved as well. And so what that means by doing that is we have 3 files then, right? We have the current working one, which may or may not have a run successfully flag set to 1 or 0. We have a backup of that file, which will either be identical to the current file because both of them have a run successfully flag set to 1, or it will be the last time it ran successfully because it has a value of 1 and the current one has a value of 0 because they've made some changes. And then the third file is the defaults. And so between those 3 files, we can then get to a point where worst case scenario, we would go back to the defaults if everything goes pear-shaped. Best case scenario is the current file runs, and medium case scenario is that the current file doesn't work, but we can go back to the last run successfully one, which is the second file, and therefore the user can get back most of the settings that they've had, potentially just not their latest change. Hope that makes sense. So then when we come to loading a file, which we've kind of alluded to a little bit before, right? I'm proposing doing a CRC check. So we should create CRCs on saving and then CRC check them when loading. And this means that we can get around if a file is corrupt, right? So let's say for whatever reason, RetroArch or Core were saving a file and it crashed, and now that config is garbled nonsense and corrupt. The CRC check at that point is a really fast way of us knowing that. And by having, and this is what we used to do all the time, so we would always have on most of our games, I'm pretty much sure all of our games actually, after pop, we would always do CRC checks and we'd always have a backup. And the great thing is, it's very unlikely something major has to happen for both the main file and the backup to become corrupt through a CRC check, because you're usually, and you should only really ever be doing this, writing to one file at a time. So worst case scenarios, best case scenario is you write file number 1, then you write the backup, the CRCs are fine, you shut the system down, you start the system back up, you do a CRC check on the main file, it's all good, you load it, right? But if for some reason it got corrupted in the save, then the backup, it wouldn't have got to the backup, right, to write it, so the backup should still be fine. Conversely, if the main file is fine, we would always, I think, sanity check the backup, or potentially just write over the backup once we're done. And so that way, if the backup ever became corrupt, as long as the main file works, and next time it saves, it's going to save both of them. So going back to this flow, the user starts the core or RetroArch. We do a CRC check on each config. If the CRC is good, then we check the ran successfully flag, right? So here what's happened is, yes, the file itself is not corrupt. It's a good file because the CRC passed. Has this file been run successfully? And my proposal is, if the answer to this is no, then we either delete this config or potentially rename it to something else so the user can manually have a look at it later, but we don't use this file, right? If it's yes, it's run successfully, then we load the file, and then we make sure that this file also becomes the backup, because this is a working file. And then we continue on to load the content. If the main file is 0, then we go down to the backup. I'll come through this path in a second. We'll come to the backup and we'll check its CRC. If the backup CRC is fine, then we check its run successfully flag, and it should be 1 in most situations, right? There shouldn't really, but we should definitely still do this check. It should never get to 0 because we only write to the backup or overwrite the backup when the flag is 1, right? So it should be, yes, it ran successfully, so we therefore load it and then run the content, and we make sure that we now overwrite the main file with this backup. And so what this means is, if the user made some changes and the file saved with those changes with a flag of 0, and they then went on to run, and RetroArch or the core or whatever crashed, then the run successfully flag never gets set to 1. And so when we come through this process on load, it didn't get set to 1, so we immediately try and load the backup, right? And if for some reason we've managed to create a file with 0 in both, then we just revert to defaults and start from scratch, right? But if it's run successfully, then we go through and we run, and it works. Okay? So the other scenario is maybe for some reason the main file CRC is not good, so we come down here. So we're going to delete that file because it's corrupt, right? We can't retrieve it. It's a corrupt file. We're going to then check the backup from the CRC, and then it's pretty much the same process. If the CRC is good, then we check run successfully. If that's good, then we now recreate the main file. So we now have a main file and a backup, both of which are set to run successfully equals 1. If the CRC, for whatever reason, is also bad on the backup, then we'll delete that file as well, and then we'll just have to revert to defaults. So obviously, it might be worth reading over this slightly slower than I'm talking over it, but hopefully this kind of is starting to make sense in your head. And then if you go back to this screen, I've tried to expand this section a little bit more. So when content is running, and this can happen if I'm in a core, I've loaded a game, I press the quick menu, and then now I'm fiddling with core settings, right? So while content is running, anytime the user makes a change, we have to set run successfully to 0, right? And the core is usually paused as far as I'm aware at this point. And so the user will resume content, and I'm also assuming this file gets saved. If the content crashes, we know that the flag will still be set to 0, right? And it will get deleted or at least moved off to the side, depending on what RetroArch developers choose to do, and not loaded next time, right? If the content runs, so like I change a setting, I go back to the core, the content runs, at some point not long after that, we should change the flag to 1, that should get saved, and therefore next time we boot the game, or core, or whatever, then we just come through and it loads up those settings, right? And if we use a process like this, my assumption is we can potentially make most stuff save automatically in the background. And sure, users can still turn that on or off, it's up to them, but my suggestion would be, in an ideal world, we turn all of this on by default, make sure this is all sanity checked and working well, and then users only turn it off if they really, really want to be anal about how they control their config files. And so it's kind of the same deal here, right at the bottom. If content isn't running and the user loads content, we still have to check our CRC, which was in the previous one, and we still have to check whether it ran successfully last time. And so based on this process, right, it will load it and run the content. So we still load the file here if it ran successfully last time and the CRC was correct. But I'm suggesting that potentially at that point, we set the run successfully flag to 0. And then maybe periodically, it can flip-flop between the two, or it just sets it to 1 not long after that. And the reason for this is I can be in a core and I can load up game A on the core, right? So let's say PlayStation 1, right? I load up a PlayStation game A on a PlayStation core, change some settings, that all works, and my config file has a ran successfully equals 1. But if I quit that core and now run a different PlayStation game, it's still going to load the same settings, but there's still a chance that that core can crash because for some reason the combination of this game and the core don't like those settings, right? And so by setting every time a game loads, a piece of content loads on a core, if the first thing we do when we transition from RetroArch into the core is set the flag to doesn't run successfully, then as soon as it loads in, it sets it to 1, then we know that the settings are good. And the more times that happens, right, eventually, presumably you go through all your content for that core, all your PlayStation games, then it's never going to have a problem. But if there's one esoteric game that causes it to crash, then we've got the backup and it will use the backup next time. And that way the user can do a little bit of debugging as to, what is the actual difference. And so potentially, instead of deleting ones that, crash, we can number them and put them to the side, and maybe that's a toggle the user can have, so that people who want to debug it can go back and compare and contrast their backup versus the one that crashed. So that kind of covers the config file suggested changes. There's a little bit more detail there you can potentially read on. Maybe the explanation might make more sense than I've described. And so now we go on to what I'm calling error checking. So one of the goals behind error checking is to try and reduce crashes either of all of RetroArch or of a particular core. So I've noticed that occasionally, particularly if you misconfigure a core can crash, but sometimes it doesn't go back to RetroArch, or the whole thing can hang, and I'm sure there's a whole bunch of myriad in-between states that can happen. So I'm proposing that we have some API calls. Maybe this already exists, I don't know, but some API calls that can happen between RetroArch and the core, so they can start communicating a little bit more effectively with each other and sending messages backwards and forwards. They don't have to be super complicated, and as I say, maybe some of this already exists. But the example here is that when the RetroArch hands off to a core, we have a callback. So the core's like, yeah, cool, I'm running, right? And so the flow is user obviously starts RetroArch, it then starts a piece of content on a core. RetroArch sets up the callback and sets core has successfully loaded to 0 as a flag. And then that way, it can keep checking, it can keep kind of saying, or there's a timer or whatever, hey, have you loaded yet? Are you good, right? And this is just for the loading part, for it to get up to I'm now successfully running, right? And so if the core loads, it sends a, yeah, I'm all good, and back. RetroArch then sets that flag to 1 in the background, everything's cool, core's running. But if the core crashes and RetroArch, after a period of time, right, we can set a timer for this, never gets a I'm okay callback, then we can now have an error, generate an error code, and I'll come on to error codes in a bit. And we can also do any memory cleanup if we need to, don't know if that needs to be done or not, and then return RetroArch back to prominence. So at least from the user perspective, they're like, okay, at least RetroArch's back up and running, and worst case scenario, they try and run the content again, it crashes again, and they get brought back to RetroArch. But at least RetroArch looks like it's not buggy at that point. The core may do, but at least RetroArch doesn't. And then, assuming that the core is now running, the next suggestion is to have a series of callbacks that the core sends to RetroArch periodically, just to say, hey, I'm still running and I'm all good, right? So when the core is running, RetroArch sets up another callback. It sets core is alive to 1, and then every n seconds, the core needs to be sending a callback saying, yep, I'm alive, I'm alive. If the core crashes, then we should have a timer running between these callbacks. This timer will expire, right? And so RetroArch will get no core is alive callback. It will set the core alive flag to 0. It can then generate a new error code, and then kill, clean up the process, whatever, and return RetroArch to the prominence. So the whole goal between that is to start, and as I say, maybe this exists, I don't know, right? I'm not an engineer, but I'm suggesting this just to make sure we're all on the same page of some things that I think would be important, and particularly when it comes to error codes, which we'll come on to in a bit. So I would suggest using these API callbacks. There's probably loads of other stuff that over time they can be added to, so that the core can start to communicate with RetroArch and set up key points or callbacks which we can then detect for errors, right, and use for errors. So potentially you could have a callback like, is joypad connected? And so RetroArch thinks yes, and then the core can be like sending a flag back going, yep, I'm getting input, all good. And if it sends back a no, I'm not, then we can generate an error code from that as well, right? There's loads and loads of little examples that we can start to set error codes for. So this brings us on to error code determination. And so the goal here with the API callbacks and things like that, as well as with the core, the config files rather, is to start generating an error code system. And the goal behind this is to create a ubiquitous, I would say, letters and number-based system that is standardized. So RetroArch is in control of the error codes, and the cores are in control of informing RetroArch of their status. And so when they pass a status to RetroArch, RetroArch can be like, okay, well, in our previous example, right, core has loaded successfully is 0, and then it times out, so therefore it's crashed. That can be a standardized error code, right, that every core can apply to. Now, some cores, and RetroArch and the core teams can figure this out, can have more nuance there. And so the error code in that small gap of has loaded successfully could actually start to get very, very specific. It's a memory leak, or, your computer doesn't have enough memory, or graphics card not found, or whatever, right? You'd have a myriad of error codes just for why the core didn't load successfully. And each code could be unique, but they're unique to that type of error. They're not unique to the core. And so if the same error occurs, or another core wants to make use of the same callback, it would generate the same error code, and then you can look that up. The goal is we add them to a support site, and you just type that error code in, and it says this is likely what's happened. And so we can start with very general ones, and then you can have a slight nuance in the number, which makes it more specific. And so best case scenario is all cores are very nuanced, and so the error codes that they're using from RetroArch system are very nuanced. But a new core, maybe when they're just testing it out or just getting used to the system, can just use the higher level ones, and it's still useful for the user, right? Like, oh, this is a config error, and then go and figure it out yourself, right? Whereas later on it can be actually it was a config error with blah, could be very useful. Hopefully this is making sense. And so I've kind of based this, I think Nintendo are really good at this. As a developer, and obviously I'm not speaking about anything that's like confidential here, but as a developer, we generally do API calls and so on and so forth. And when stuff goes wrong on Nintendo's kind of OS-y backend, it generates all the error codes, right? It's not like the developer's generating an error code there. And they're great because you can go on to Nintendo's website, you can type them in, and it'll be much more specific. Like, oh, you've not plugged into your USB Ethernet box, right? Or your Wi-Fi settings are incorrect. And so we can get down to quite granular detail with that. And we can also use this to actually put up pop-up alerts with a generalized message, and then you can search the code on the website and it will give you much, much more detail. And I think that's a really nice halfway house. So I'm presuming most of us have seen this on Nintendo systems. If you get a Wi-Fi error, let's say you're trying to play a bit of Mario Kart online or whatever, and it disconnects, or it can't connect, they'll give you an error code and they'll give you a generalized message, like maybe like your Wi-Fi is off or whatever. But if you take that error code and search it, it'll be a lot more detailed than that generalized message. And so generally speaking, it means that Nintendo don't need to have 6 million different error messages in the actual machine. They can put all of them on the website, and they can update them as they determine new ones. Yeah, so this section is for talking about kind of development priorities. So there's likely loads of places that you could make use of API callbacks and generate error codes off them. My suggestion would be to try and figure out what the most common bugs are and most common complaints that users have, and use callbacks, flags, error codes, and etc. to start tracking those and start helping users with them. And then if something currently doesn't happen that often, it isn't something that users talk about a lot, then potentially it's not worth the effort to put the API callback or error codes or flags or whatever in. I mean, sure, if get to the bottom of the pile and there's nothing else to do, but I would be triaging, and it's fairly common sense, right? Triaging the biggest impact areas first. And so the final section that I'm going to cover today is talking about how we can start to bring some of this information forward to the user in the form of alerts. So I've mocked up in Figma some alert pop-ups. You can see the first one here. So I've tried to stay fairly in tune with the RetroArch Ozone UI style. Obviously, the other ones would have to mimic this in their own style. But the general gist of it is take up full screen, remove any ability to input anything else that's going on, and also bring RetroArch to the foreground if it's something to do with the core that user needs to be informed about, and be quite clear about what's going on. So we have a title at the top here. In this case, an error is going on, right? The core's crashed, so you put the name of the core, the error type, which is the generalized title of the error, and the error code. And then I've added additional information here. So you can see here, the first note is, for further details, please enter the above error code at support.retroarch.com. I've suggested that as a website. So putting that code in would then give much more specific details, potentially, about what the actual error is. And then below it says your config file for this core has been backed up and reset to the last working version. So that obviously information should change based on what's actually happened. But in this case, potentially we've moved that backup, that current config file to the side, and we're using the last working version because there was one. If there wasn't a last working version, then maybe we would say has been reset to the default. So something I'm suggesting, which you can see when you read the text over here, is that there's a couple of rules, several rules I'd like to try and apply for this. One, if there's more than one option, and you'll see that in a second, if there's more than one option, we always default, i.e. highlight in blue, the least destructive option. And if anything is destructive or can forcibly change a setting, we should always make sure that the user is asked to double confirm. So you've seen these, Nintendo's very good at this, blah, 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 okay or cancel, and you click okay, are you sure? Yes, I'm sure. Okay, cool, change is being made, right? And that's particularly important if for some reason we wanted to actually say here, do you want to use the backup or do you want to revert to defaults? We should definitely do a sanity check on that, because the user's writing data and they might be like, oh, actually, no, that's the wrong one. And then it's too late if we don't have a double confirm. I'd also suggest that internally, behind the scenes, the RetroArch team split these alerts up into 3 categories: errors, warnings, and notifications. And I would suggest that the user can't turn off error pop-ups because they're critical. Warnings and notifications, we can potentially have separate toggles or settings so that if people are like, I really don't care about warnings and notifications, we can just turn them off. And so we can use this window, which you'll see in a second, for quite general information, which are more on a warning or notification basis, as well as using them for like, hey, something majorly bad's happened and this is what we're doing about it. So 2-button alert is probably one of the ones that's going to be used in situations like playlist scanning, and it also can be used when you've got an OK and cancel option. And so, I mean, it's basically the same deal, right? You've got a title, and then you've got the text about telling you what's happening, and then the user's got two options. So in this case, I'm suggesting that at the end of scanning a playlist, which is a bit of a funky process at the moment in RetroArch at the moment, because you choose to scan, you browse to a folder, and then once you get there, you scan, and there's not much that tells you that it's complete, and you actually just end up on the same screen. And so for a lot of users, they can be like, has anything happened? Is this finished? Where do I go now? And the way to get back, albeit which is relatively straightforward, is still, I think, potentially confusing for the user, is they have to go back. And my feeling is the reason that's there is because some users like to go back one folder and then add a new folder and scan that one, which I get, right? And so what I'm proposing is, once that process is end, we trigger a window like this. We then tell the user what's happened, right? So this many files were scanned in this many folders. We found this much content, and we added to this many playlists. And then we can give them a little bit of info. So existing playlists have been updated with any new additions. New playlists are being created where appropriate for any new platforms. Playlists are available in the sidebar. And so most users who are experts or developers are going to be well aware of all of this. But I think for novice users, this is probably going to be quite helpful. And then the two options, with the default being done, because it's non-destructive, you just click done. And my suggestion is you click done and just get taken either to the playlist or back to the main menu or somewhere out of scanning playlists. And then if you really want to scan another folder, you do that, and then it takes you back to the browser and you can go back up and whatever. And so these sorts of windows, pop-ups, could be used for these sorts of warning/notification things, particularly when a process completes. If the user sets off a process, it could be useful, and I realize that some users might find it annoying, but it could be useful, like say you set a background scan for covers. It could be useful at some point if this pops up once it's completed and says, blah, blah, this many covers are found, for this many games, there are this many missing covers. It could be that some of them are misnamed or blah, 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 right? And then you would just click, probably just be a one toggle, done, right? Or okay. I haven't thought of an example for how to use a 3-button one, but I figured there might be a need for a 3-button one. So it's here, and obviously the text can be changed and modified as appropriate. And again, I would suggest that the selected action is the most non-destructive or the least destructive option. Yeah, so in essence, and this is the last slide, in essence, the summary is I think it would be worth finding ways to back up config files, utilize dirty flags, CRC checks, and ways of assessing whether a config file ran successfully, as simply as possible or not, so that more of the saving can be made automatic and in the background. I've also proposed API communication and error codes systems so that RetroArch can better understand what's happening in a core, understand whether it's running or not, and then utilizing these, the final suggestion, which is pop-ups, alert pop-ups, utilize them to better inform the user as to, as you can see back here, as to what error has happened or what it's just completed and maybe what the user might want to do next. So hopefully you found this useful. I've got still a design that's kind of floating around in my head that I might put together. But other than that, I feel like unless the RetroArch team see this or the previous videos and request more work, that the main bulk of what I'm offering for the team is kind of done for just now. I'm happy to do more of these and step into more of it, but I'm kind of more looking to the team for feedback and suggestions on where they would like to drill down or anything that needs to be surfaced. So thanks for watching, and I hope you found this enlightening, entertaining, beneficial. Thanks very much.